So good afternoon. Hope this video is finding you well. I've had a couple of requests this morning to make a video to discuss the Heat of Neutralization Lab. So what I've done is I've changed the data just a little bit so that I'm not doing the lab directly for you, but give you an idea about how you're doing this. A basic idea of the Heat of Neutralization Lab is that you're taking two chemicals, an acid and a base, and you're combining them together. These chemicals are reacting exothermically, and they're changing the temperature of the solution that they're in. They're increasing it because they're releasing bond energy. Okay, I think you can see this from the fact that we start both of the solutions at 20 degrees Celsius, and they wind up being 27 degrees Celsius at the end. I kept the 1 molar solution and the 0.030 liters of HCl. Okay, so the temperature change of the solution mixture was going to be calculated as 27.0 minus 20.0. Again, you're doing T2 minus T1 to get a temperature change. This gives us a positive 7 degrees Celsius. Okay, the total mass of the solutions, assuming a density of 1 gram per milliliter. Well, in order to know the mass, I need to know how much volume both the solutions were. If I look up in the procedures, it says that there's 50, that I'm obtaining 30 milliliters of a 1 molar solution and 30 milliliters of another 1 molar solution. 30 plus 30 is a total of 60 milliliters. So we're going to assume that we have a solution of 60 grams because it's 1 gram for every milliliter. The specific heat of the solution, assuming the same specific heat as water, we're assuming most of this is water. That's one of the assumptions in the lab. So we're assuming that both these solutions have a specific capacity of 4.184 joules per gram degree Celsius. Okay. How many moles of HCl were used? Well, to calculate this, we're going to take molarity equals moles per liter. If you remember, it said up at the top that we were using 1 molar hydrochloric acid. We want to know how many moles there are, and we know that we used 0.0300 liters. So we want to know how many moles there are. We're going to multiply both sides by 0.030 to find out how many moles there are. No calculator needed on that one. We did that on purpose to make the math easy to do. Next, heat of neutralization per mole of HCl in joules. So I need to calculate what the heat of neutralization was. Heat is energy, right? And notice the units are joules per mole. Oops, I skipped over something here, didn't I? I didn't do heat released by the neutralization reaction, so let me do that first. Q equals mc delta T. The heat is the energy. So I'm searching for Q here. I know that I had 60 grams multiplied by 4.184 multiplied by my temperature change of 7 degrees. Okay, so calculator here, 60 times 4.184 times 7. Q is going to wind up being somewhere around 1,700. And I'm going to use 3 sig figs, so I'm rounding this to 1,760 joules. So I got 1,760 joules for my 0.030 moles of solution. I've got 1,760 joules for my 0.0300 moles that are in that solution. When I get to heat of neutralization, that's measured in joules per mole. So literally, I'm going to take the amount of joules, 1,760, and I'm going to divide that by the number of moles, which is 0.0300. 1,760 divided by 0.0300 is big number, 58,700.
You're not playing any games on your computer.
If I want to convert that to kilojoules per mole, that's just converting to kilojoules. So I move the decimal over 1, 2, 3 places. So it's 58.7 kilojoules in 1 mole. I hope this video has been helpful. If not, please shoot me an email and let me know exactly how I can help.